Okay, guys, we're going to start off today with simplifying radicals in 10.2. And we've already kind of covered this back last chapter. We had a section where we did simplifying radicals. We're going to get into a little bit more detail in this chapter with these, which is why I kind of chose to go over these. If you take a look here, a radical expression is an expression that has radicals in it, or has a radical symbol in it. And a radical expression is simplified if, and this is kind of the important part, if the radicand has no perfect square factors other than 1, and then we talked about that one, if the radicand contains no fractions, and there are no radicals that appear in the denominator of a fraction. These are the three things we're going to talk about here with some practice problems that we're going to do today. You can simplify radical expressions by using your multiplication and division properties of square roots. We went ahead and already, again, this is what we did last chapter. We have radical 48 here. For this example, you can break radical 48 down to 16 times 3 inside the radical. If you take out then a square root of 16, you get 4 on the outside. So turning this into that, 4 on the outside, then you're left with radical 3. So 4 radical 3 would be the simplified version of this expression. And then you can do the exact same thing with variables. Cube root right here, this part right here, the radical n cubed. You have actually n squared times n, which is what you have there. The n squared, the square root of that, n can come out, and you're left with n radical n as your simplified version of that expression. Again, we already covered this last chapter, so hopefully we get a general idea of what to do, which should make this a little bit easier as we move on into the next couple of sections. What I'm going to do here, I'm not going to cover all of these to save you a little bit of time, but I am going to cover maybe some of the harder ones. Like, for example, we're going to do D here. D says negative m, or opposite of m, radical 80 m to the 9th. There's a lot going on there. So we'll start with, we're going to break down 80 using the factor tree. 80 is actually 8 times 10. 8 breaks down to 2 times 4, which is 2 times 2. 10 breaks down to 2 times 5. So those are all of our factors here, which means we have 4 2's times a 5 times, and I'm going to go ahead and break this down a little bit, m to the 8th, because I know that I can have a perfect square of that times m. So if you look at have the rest of it the same. If you look at what I've done so far, I have kind of broken this down into some easy square root factors that I'm going to be able to pull out. What is inside the radical is equivalent to what I have up here. But again, if you look, I broke this down so that I could say, okay, I've got negative m outside. The square root of 2 to the 4th is 2 squared. That is the factor of that. So 2 squared comes out, and that's gone. There is no perfect square of 5. So there is no square root of 5 that's going to be able to come out and be good. So I can leave that in there. This m to the 8th, if you remember, comes out to be m to the 4th because of our, when you have common factors, you keep the base, add the exponents. M to the 4th times m to the 4th is m to the 8th. And that's for the multiplication property there. We did that much earlier in the year as well. So I get rid of that. And what I'm left inside the radical is 5m. Now I can just clean this up over here. 2 times 2 is 4. It's going to be negative. And then I can keep the base, add the exponents. Remember, that's a 1. 1 plus 4. Don't forget about the radical 5m. That right there is the answer. Negative 4m to the 5th, radical 5m. Hopefully makes sense. Again, we've already done this before, some easier ones. We're getting into some harder ones here. We'll go ahead and do E also, because E is a little bit of a trickier one. 2 radical 7t times 3 radical 17t squared. Okay, so first, let's go ahead and do this. I can do this. 2 times 3 is 6. And then inside, I'm not going to do 7 times 14 because it's going to give me a larger number that I'm going to have to break down. But if you think about it, okay, inside of this, I'm going to go ahead and put these together. 14 is 7 times 2. And then right here is another 7. So I've got 2 sevens times a 2. That's 14. If I factor trade 14, I have 7 times 2. I have another 7 here on the left side. So I have 7 squared times 2 times, let's look at the t's. I have t squared, and I have another t over here to the left. I actually have 3 t's, but again, if you think about how we did it over on the problem on the left, I've got it kind of broken down into perfect squares here that I can pull out of the radical. Pretty simple. We'll go ahead and use another color here. So I've got 6 on the outside. And if I square root 7 squared, I'm going to get 7 that can come out. So that gets rid of that. The 2 has to stay, but then I'm left with t squared. If I would square root t squared, I get t, so that whole thing is gone, coming out of the radical. And I'm left with, inside the radical, 2t. Now I go ahead and put it all together, and I've got 42t radical 2t. And that is my answer for that. So again, hopefully these are making sense. You're kind of seeing what we can do here with these. Go ahead and do f together. 18 breaks down into 2 times 9. 9 breaks down to 3 times 3. 6 breaks down to 2 times 3. So let's go ahead and put these whole things together. 3 on the outside, radical. You look, I've got 1, 2, 3 3s. Okay. So let's go ahead and write it like this. I've got 3 3s, and I've got 2 2s on the inside. So now I can go ahead and start thinking about what I can pull out of the radical. When I'm pulling out of the radical, I'm looking for perfect squares, what square roots, or 2 of the same factors that I can pull out. If you look at this point here, I'm going to focus right here. I've got 3 3s. 2 of them are perfect squares. Okay, if I take 2 3s out, that's a perfect square. I can pull that out. And I'm left with another 3 on the inside. So I'm going to do this. Okay, if I were to pull 2 of those out, it ends up being 1 on the outside. Okay, and then I'm left with on the inside here, another 3. Hopefully that makes sense to you guys. 3 cubed is, if you did it, it's 27. Inside of 27 is a perfect square, which is 9. If you pull that out of if I square root 9, I get 3. That's where this number came from. And I'm left with a 3 on the inside. The 2 squared is actually a perfect square, which means I can just pull out a 2. Okay, if that was to go back on the inside, it would be 2 2s, which would be 4. And then we're good. We just got to clean this up. 3 times 3 is 9. Times 2 is 18. Radical 3 is my final answer for that. So hopefully this kind of gives you a good idea of what we're doing here with simplifying radicals. Like I said, we did this earlier, but it becomes a little bit more challenging. It's a lot more in depth, throwing some variables and some more difficult things in there to talk about. Let's take a step down here to the division property of square roots. And all that means is this. All that means is when you've got something like, you've got an example up here, square root of a and b, when you've got a fraction inside of your radical, you can split it and make it into 2 different radical problems. And then you can kind of work it out that way. So the example here would be, what if I had 36 over 49 inside the radical? I can split it to turn into that. Square root of 36 is 6 in the numerator. Square root of 49 is 7 in the denominator. And then that is my answer. It kind of leads us to what we're going to have to do after in the next part of this. So, and we'll kind of get into that. But just go ahead and split those. Put the numerator inside of a radical on the top, the denominator inside of a radical, and then go ahead and simplify that way. Let's go ahead and do b here. A is going to be just like that. Let's go ahead and do b. So let's go ahead and split this. So we have radical 8x cubed on top over radical 50x. 8 breaks down to 4 times 2. And then x cubed is x squared times x. All of that inside the radical. Okay. Again, I'm breaking these down in my head with what are, if you look, I have 4 here, and I have x squared, which are perfect squares. It's going to allow me to square root those, pull them out of the radical, and make this a little bit easier to simplify here at the end. The denominator, I'll do the exact same way. Radical 50x is actually 25, which is a perfect square, times 2 times x. And again, that's a perfect square. I'll do this in a different color now. So I'm going to go ahead and simplify the numerator. The numerator turns out to be, here in blue, 4 comes out of the radical and becomes 2. And the 2 is left on the inside. X squared comes out of the radical and becomes x. And I'm left with inside the radical 2x. Same thing here in the denominator. 25, if I pull that out of the radical, it becomes 5. So that's gone, and I'm left with radical 2x. This would be good, except just like a fraction. If you take a look at it, there is a common factor in both the top and the bottom, the radical 2x, that I can cancel. You are allowed to do that. And you are left with 2x over 5 as your final answer for that. Hopefully that makes sense. Again, there's plenty of videos online. If you look up simplifying fractions in the different parts, they'll be able to give you a little bit. It's going to be the exact same thing, but a couple more practice problems to help you out with things like this. We'll move on to C here. Radical 36a over 4a cubed. We'll split them, and I'll go ahead and do, we've got radical 36a on top, and then radical 4, and then a cubed is actually a squared times a. Anytime you've got an odd exponent for your variables, you can just pull one out, and then the rest of it is going to be the perfect square. So if you've got 3 for your exponent for a, take one of them out and make it a squared, and you have the a separately, then that a squared is actually your perfect square that you're going to end up pulling out of the radical. So here we go. If you look up at the numerator, we'll go ahead and do this in a different color. Do the green. Square root of 36, I can pull that out and it becomes 6. Radical a in the numerator. In the denominator, square root of 4 is 2. And then I'm also going to pull out a squared times a. I'm going to pull out an a and be left with radical a. It all looks pretty good, except for I need to do some simplifying. Radical a's can cancel. 6 and 2 actually simplify to 3 in the numerator. So what you're left with is 3 in the numerator, a in the denominator. That is your simplified radical expression for that. Again, same type of problem as B, just some different numbers. Hopefully you can get these little quick tricks or hints to kind of move the questions along a little bit easier. The last thing we have right here is when we have a radicand in the denominator that is not a perfect square. So the problems that we just did, if you look in the denominators, all of these denominators were perfect squares. 49 perfect square there. But we ended up canceling some things out to where if you look at our final answers here, none of our radicals, none of our denominators were left with radicands in the denominator. It's not going to be the case for these back here. If you look, these are already simplified. If you look at a, for example, radical 7 over radical 8n. I can't do any more simplifying. There's absolutely nothing I can do. 8 breaks down to 2 times 4. There's nothing here that I can do to simplify this anymore. So when that happens, if you're working, you end up with a radical or radicand in the denominator, you have to do something special. And that's going to be this right here. You have to multiply by this exact same thing with both the top and the bottom. Here's why. When you multiply radical 8n times radical 8n, you would end up with here radical, think about it, radical 64n squared, which makes it a perfect square, which means you pull out the square root of 64 is 8, square root of n squared is n. No more radicals in our denominator. That's what we're trying to get to. You cannot have a radical in the denominator of a fraction. That's what we've done. And then up top, 7 times 8 is 56, n inside the radical. And then at this point, you have to decide, okay, can I simplify? And I'll just go ahead and tell you, you're going to be able to simplify this, but sometimes you can't. Sometimes you're just going to have to leave it like it is, and that would be the answer. But if you look at it, 56 breaks down to, if you factor tree 56, it breaks down to 8 times 7. And then 8 breaks down to 4 times 2, and then 4 is actually a perfect square. So what we end up with here is go ahead and put this over here. What we end up with is, up in the numerator, we have radical 7 times 4 times 2, okay, times n. Again, all of this is 56n over 8. That 4 right there is a perfect square that I can pull out. 2 radical 7 and the 2 become 14n, and that is simplified. I cannot do anything with it, over 8n. And again, we're good so far because the denominator does not have a radical. You're not allowed to have a radical in the denominator as part of your final answer. And guys, this is almost perfectly good, except for we have to simplify the 2 and the 8, and we end up getting radical 14n over 4n. That is our final answer. You can go ahead and do D as well, same type of a thing. Can't have radical 3 in the denominator, so we'll go ahead and do that. Radical 3 times radical 3 is radical 9, which is actually just 3. Just 3. That's why we've gotten rid of it. Up top, we have radical 21x. 7 times 3 is 21x. And if you were to go ahead and simplify that, I'll just go ahead and show you. It would be radical 7 times 3 times x over 3. None of this can be simplified. The 7 is not a perfect square to come out. The 3 is not a perfect square to come out. And just to warn you, you cannot simplify that. Okay? This 3 is outside the radical. That 3 is inside the radical. So that 3 is actually not a 3. It's the square root of 3, which would be a different number, a different factor than 3. So you cannot simplify that at all. So don't try to do that. So what you end up with is actually what we have right here, radical 21x over 3. And that is our final answer. And then that's it, guys. That is the lesson here from 10.2. Hopefully it makes some sense. Again, there's a lot going on. We are getting into it with a lot more detail than what we did in the last chapter, and that's good because you're going to need this, especially when you advance into Algebra 2 in your math education. So hopefully this helps. If you have any questions, be sure to email me and get a hold of me, and I'll go ahead and help you out with that. All right? Thanks, guys.